artificial intelligence. These two video tape I found in my desk when I came to my office first time. I think my predecessor left it for me, but two of them is from AI. So if you can see the image there, it says AI tape, and the next one is Genetic Programming 3, Human Competitive Machine Intelligence. I don't know what inside. Right? I don't have the player, right? So I will ask library to convert it into DVD, and then maybe we can watch it later. Okay, let me start with Bible. Bible foretell human lifespan, right? The years of our life are 70, or even by reason of strength, 80. Yet the span is but toil and troubles. They are soon gone and we fly away. Do you know where you can find this verse? What book? Psalm, yeah, right. I think I can get Psalm 82. I can give away something. So make it more fun. So, but if you can answer, you can have. Psalm chapter 90, yeah. Is it really? Yeah. You had like 150 guesses. Okay. So that's Bible, right? Bible. Now AI claims it can predict your lifespan. Not overall human, but exactly you. How about that? Okay. Start with simple examples, right? So this is you. Assume this is you, right? And you have parents, right? And you have grandparents from both sides, right? Assume all your parents and grandparents already dead in this story, right? Disease, right? And you know their age, right? Their lifespan, right? Okay. And I will say to you, if I add all of the ages from your parents and grandparents, okay, multiply it by 1/6, right? Because there are 6 totals, right? Parents and grandparents, right? So take the average in simple term, right? Take the average. It should be your age. That's from AI perspective. Okay. Easy, right? Makes sense?
Does it take into account like sickness? Like
yeah, no.
All that stuff?
No. Simplified. This is very, very simple, right? Without head scratching. Simple version. Okay? Simple, but it's true. It's powerful. Later we will add some other component. Okay? Just simple one, right? Simple examples. Right? Is that clear? Okay. If we want to be more accurate, now we use big data. Okay. Can I close this one? No.
I don't know.
Can I hide it somewhere?
If you click on the 3 dots, does it give you the option for hiding?
No.
No.
Okay, I will just move it around.
Yeah.
Okay, so now you will have parent of your grandparents, grandparents, right? Okay, add them all, gain, right? And then you can find out more accurate prediction. That makes sense, right? More data, more accurate. Okay. Okay. Now let's go to our brain, right? How our brain works, right? This is a neuron. Okay. But I will not explain all the terms, right? But pay attention for a neuron, the dendrite, right? This one, dendrite, will get a stimulus from outside, right? And after gets this stimulus, will have electricity goes to the axon output, right? And goes to another neuron or to the synaptic terminal, right? Okay, is that clear? So the same one here become neural net. Okay, this one is neural network, the simplest version. Okay, so here is your input, the age, remember, right? Your input, and then you have weight. Remember, we have uniform weight, all 1/n, right? Because we want to take the average. But for example, you can give, oh, I will consider my parents' age more weight than my great-great-grandparents' age, for example, right? Because they already like lived long time ago, and the situation is different. They don't have COVID at that time. Now they have COVID, right? Okay, that makes sense, right? Okay, so I put more weight on my parents, for example, right? Okay, so I put weight there. Do the same thing, summation, right? Easy. But now I have activation function. Okay, so because in this part is linear, right? It's all linear. But now I introduce non-linearity. I can put any function there to make it more real, right? I put any function and the activation. That's it. Simple, right? That's the basic unit of neuron. But imagine have this neuron like million of them and interconnect to each other. That's neural net. Okay? Easy?
So just to clarify, the idea then is if you put several of them together, the activation of one could be an input for another one, right?
Yes. Here, let me draw input. So you can have, this one is input, right? And then you can have middle layer. And you can have several middle layers, not only one, right? Right. And now you have output. Now you can interconnect. Oh yeah, this one goes to here. Right?
And all those lines would have different weights.
Yes, right, exactly. Okay. You can select, oh yeah, I don't want to connect this one, is okay also. Right? You can create your own connection. Okay. And so on, right? But in here also do the same. Try to connect. Right? And so on, right? Here. Okay. And you can have more. Oh, here is for the output. Okay. So if you have the data, right, the input data, right, Now you have the output, and then you have target. Now, I will add one more here, target. So for the first time, we will compare the target because we want to train the neural network. Right? So we put the inputs, right? Calculate all the weights, compare it with the target. There is some error, right? And now here is the clever trick. Here is the difficult part. Now I have to propagate the error back to update all the way. Update all the way. So next time we see the same input, it will produce less error. Is that clear? Okay. So that's the basic idea. Okay. Now, same concept. I apply it to time series. Okay. You might start asking, what is time series? Because we have a time in here, right? Or we call it period, time, whatever you said, right? But it's a sequence now, right? Imagine this one is week 1, week 2, week 3, for example. Okay. And on the left side, yeah, we can use price, right? For let's say vegetables, right? The price of vegetables on week 1. See the actual, the blue one. Okay. So we go to the market, take the data of the price at week 1, week 2, week 3, and so on. Okay. Now I can have moving average. So for example, the red one, after I see two data, I calculate the average. Okay. And it becomes the prediction for the next one. Okay. And so on. So I can predict for the next one, right? Based on the past data, right? I can also increase the interval. Instead of just 2 weeks, I will have 4 weeks, right? Should be more accurate, right? Same concept, but we apply it to time series data. Okay. And then we can refine, put some non-linearity and so on to prediction, to make a better prediction. But same concept. Using different function instead of just linear, just average. I have some weight also, right? Yeah, you can apply the same concept here. Okay, but based on this one, we can predict what's next. Okay, is that good? Okay, so application. So I spent 1 year as a data science expert for AUSIT. AUSIT is Australian Indonesian funding, right? Or yeah, Australian, like government to government, right? G2G level. And Prisma is promoting rural income through support for market in agriculture. So I spent 1 year to collect vegetable data, try to predict their data for next month. Okay. And I also collect weather data from NASA because Indonesia still lack of data, even for the government, asking the government and asking like, do you have data? No, we didn't record. We just use intuition. So that's another problem, right? If you don't have the data, then you cannot use neural network for sure. There is no AI. Okay, but if you have data, then you can use, right? Okay. For 1 year and then become these apps. This is the front end. I didn't do the front end, but I do the back end. I do the crop planning section. So based on the market data and weather data, and then I give suggestion to the farmer to help them pick which vegetable to plant. Okay. Is that simple? Right? That's your question maybe. That's it. That's neural network. I don't have to go to graduate school for that one. It's such easy, right? Well, there is another part that Bible tells us, toil and troubles, right? This is the part that you will scratch your head. For example, I will ask, what is the difference between AI, machine learning, computational intelligence, and data science? That's the big terms now, right? Everywhere you see it. If you look for job, this is also the high paying job, right? Okay, so let's see one by one. So for artificial intelligence, you can go to special interest group. ACM has SIG, right? Special interest group on artificial intelligence. Right? That's the website. You can go there. You can subscribe also. They have like free publication also, so you can find out more about artificial intelligence, right? And they are trying pushing AI literacy. So they are considering for this new age, if you don't know AI, it's like you are illiterate. You don't have your GED certificate, right? You cannot read. Imagine someone cannot read, right? That will be disastrous, right? You cannot do almost anything, right? It will be difficult. So they are trying pushing that one. Baylor also have a new website, Baylor.ai, and they are looking for graduate students. So if you are graduated and you said, I want to research more on mathematics, looks like fun, right? Playing around with data, you can apply. The new director is my best friend, so I can write recommendation also. So what is AI? Now we will get. So I already discussed neural network, right? But they have cellular automata, bio-inspired, nature-inspired algorithms, right? Search and machine learning algorithms. So machine learning now under AI, right? Okay. The new term now, deep learning. Basically, it's just same thing there, but instead of just one dimension, like here, right? Now I have it as a grid or the pictures, right? And this process, multiply and addition, right? They call it convolution. Or dot product in matrix. If you learn linear algebra, right? Matrix theory, right? Factor, remember? Okay, but they call it deep learning now. Neural networks again, right? So swarm intelligence, evolutionary computing, nature-inspired, right? I will discuss most of them in my class next year, next semester. Right? If you are interested in this one, I can give you more information. Okay. But you can have also the next one in symbolic artificial intelligence. This is from their publication, the newest one. I took it today, and I will put it in the drive also, so you can see their publication. Okay. But yeah, you will find like more sophisticated term. Okay. What is machine learning? We know that's under AI, right? Under the AI big umbrella. But machine learning basically study of computer algorithm that improve automatically to experience. Right? So we give them experience here, start input, right? And the whole weight here will update it, right? So the computer, the model will learn from the system, from the experience. If you give them more data, they will learn more, right? Be more sophisticated. Okay. So basically, that's machine learning. Usually, when we program, we have some problems, and we design specifically for one problem, right? But now we design it for learning by itself. Okay. So one algorithm for all the problems, right? You just need to give them examples, right? More data, more experience, then the algorithms will become mature by itself. Okay. And then this definition from Tom Mitchell, this guy. Right? That's the website. So you can click and learn more. And this one is Andrew Ng. That's from Stanford, also famous for the course. Baylor also use it. So we follow Andrew Ng course directly per lesson. Okay. So if you want to learn more, you can do that. What is computational intelligence? So you can go to robertmarx.org. This one is from IEEE. That one for SEM. This one is from IEEE. And define. Okay. And Dr. Mark is my advisor. He is the founder of IEEE Intelligence Society. So he is the big guy. So he wrote, you can go to the website, download all the material here, but there are, one is the roots, so like the history, right? He has 90 pages long history, and then there is a short one, intelligence, computational versus artificial, that a short paper, like 2 or 3 pages. So you can see also, in short, what is the difference between artificial and computational, right? And the last one, if you don't like to read, there is a video also. Okay. So basically, this one is the main focus for almost similar, covers most similar things, but these 3 is in the course. So we will learn more about fuzzy logic, right? Because in our world, it's not binary logic, it's not true and false, but we have like multi-value logic. Okay? Not only true and false, right? I hope it's as easy as true and false, everything true and false. But yeah, search and learning, that's another algorithm. Swarm intelligence, but AI also has it also, right? Swarm. So next, data science, right? Data science. This one is from another professional organization, SIAM, right? More mathematics side, right? More heavily on the mathematics. But the good one is this one, learning from data. I also took this course, but it's also free, so you can try and ask me if you try and then you don't understand. You can ask me. Okay. I think that's the end of my presentation. 24 minutes. Yeah, I think I'm good in terms of time. Any question? Okay.
All right, guys, don't want to keep you too long. We just have some exciting updates on MacGT. which, by the way, is a hackathon that we're looking to join in October. The hackathon is free, so we'd like